Recalculating electron microprobe analyses. Again, analyses are reported in weight percent. The analytical error is typically 1 to 2% total or of relative for all values where there's more than 2 to 5 weight percent of the element. Totals therefore should be 100 plus or minus 2%. We need to preserve significant figures. In this case, we opt for 3 figures, i.e. 12.1 weight percent, or 4 figures, 12.12 weight percent. We recalculate into atomic proportions to be able to write mineral formulas. And then we normalize to an arbitrary number of cations or anions per formula. For example, for olivine, the stochiometry is MgFe2 SiO4, and therefore the number of oxygens is 4 in the normalization. First, we'll look at olivine. Here, we'll check the totals. You can see it's got silica, dioxide, FeO, MnO, MgO, CaO, and those total to 100.78 weight percent. This is within 2 weight percent, so it's okay. Now we're going to divide by the oxide mass, and you can see the oxide masses in this column. SiO2 is 60.08, calcium 56.08. When we divide that, we get the molecular proportions of these oxides over here. So 0.5 for SiO2, 0.0014 for calcium. Next, what we're going to do is we're going to convert the moles of oxides to moles of oxygens. For example, most of these are 1-to-1 cation to oxygen, but silica is 1-to-2, and therefore we have 2 oxygens per silica, and we convert 0.5008 to 1.002. Now we sum those up, and it turns out the total is 1.996 oxygens per formula unit. And now what we're going to do is we're going to normalize to 4 oxygens, which is the number of oxygens in olivine that we've assumed. And we do that by creating this normalization factor. It's going to be 4, the number of oxygens we assumed, divided by the atomic proportions of oxygens, F, 1.996. And that factor is 2.004. So we multiply this times this column, and we get these sums. And you can see when we add those up, the totals gives us 4 oxygens per formula unit, as we want. Now what we're going to do is we're going to convert these oxygens, which are now normalized to the correct amounts, back to cations. And that means we have to do the same thing we did before, and we could assign 1 iron for each oxygen, like that, and we assign 1/2 silica per each 2 oxygens. And we get this as the proportions of cations. So 1.004 silicon, 1.936 irons, etc. And the total number of cations is 1.99, which again is within the 2% error. And you can see what the formula looks like. It is olivine composition. We have roughly 1 tetrahedral silica per formula unit and 1.99 octahedral cations. That's all of these. And we can calculate the iron to iron plus magnesium ratio, or the magnesium plus iron. This is a very iron-rich olivine, so it is a phthalate composition. Thank you.